Okay, on the second part, we will be talking about the trigonometric functions. Specifically, we will be talking about three of them. Trigonometric functions are defined by the ratios formed using the side lengths of the triangle. When we talk about ratios, we are going to be dividing two quantities. Let's again take a look at this triangle first. From last time, we already know that this side, the longest side of a triangle, is called the hypotenuse. That is the side opposite the right angle. Let's label the corners as capital A, B, and C. And let us consider this angle formed by A, B, and C here as our angle of interest. We are going to get the trigonometric functions of this particular angle. Our symbol for angle is the Greek symbol theta, theta. We can see that opposite this angle is one of the legs, and we will label that as side opposite of the angle theta. And the other leg is the side beside the angle, which we will label as side adjacent to the angle. Adjacent means beside. Okay, so this is going to be the labels of the side if we consider this as our angle. But what if we consider this as our angle? So your labeling would have to change. So the opposite side of this angle is this, BC, the length BC. So we label this as side opposite theta. Here, beside the angle is side AC, which should be actually side adjacent theta. Okay. Okay, let's now define the trigonometric functions. So let's consider this triangle. The three trigonometric functions would be the sine function, the cosine function, and the tangent functions. What you can see here inside the parentheses would be the mnemonic devices that we will use so we can remember their ratios or their formulas. For the sine function of the angle would be the ratio between the length of the opposite side, meaning this side AC, divided by the length of the hypotenuse, meaning side AB. That is why your mnemonic device is S for sine, O for opposite, and H for hypotenuse. Cosine function of the angle would be adjacent over hypotenuse. That's why you have K, CA, and H. So what is adjacent here is side BC, and of course the hypotenuse is side AB. The tangent function is the opposite over the adjacent, TOA. Opposite is AC here, adjacent is BC. So if you want to remember the three functions, just say so, ka, towa. Okay, let's use that in calculation. Let's say we have this triangle. So the hypotenuse is 7 centimeter. These are the remaining legs. We are considering this angle. We want to get the trigonometric functions of this angle, meaning the ratios of the sides of the triangle if we consider this as our reference point. So that means that since this is our angle, the opposite side would be here, side BC. The adjacent side would be side AC, and of course, AB is our hypotenuse. So solving for the sine function first, sine is opposite. So that's going to be 6.3256 divided by the hypotenuse, which is 7 centimeter. So if you get the quotient, this is what you will be getting. Cosine, K, adjacent over hypotenuse. Adjacent is 3, and hypotenuse is 7. So again, report 4 decimal places, 0.4286. Tangent is opposite over adjacent. So opposite is this, 6.32. Adjacent is 3. So if you get the quotient, if you get the ratio, this is what you have. Okay, so these are the values of the three different functions considering this angle. Let's have another example. Okay, this time we will consider this angle. But here you need to do an extra step because one of the sides, the hypotenuse, is not given to you. Only the two legs, the values of the two legs are given. You are not also specified the units, but that's okay. So again, what do you need to do in order to solve for the length is use the Pythagorean theorem. So here I will be showing a shortcut already since you already know how to do that. A squared plus b squared is equal to c squared. The answer would be 13. So c is equal to 13. Now we can solve for the functions. The sine function opposite of this angle is 5. Hypotenuse is what we just solved. Letter C, that's 13. This is the answer. Cosine is adjacent, 12. Oh, this should be 13 instead of 3. Let me just fix that. Okay, so 12 over 13 is 0.92, 3 and 1. And solving for the tangent function, opposite is 5, adjacent is 12, 0.4167. Okay, so this is very procedural. Just don't make mistakes identifying which is the opposite side, which is the adjacent side. Okay. Okay, now we have a similar looking triangle from sample number 2, but this time instead of this angle, we are considering this angle. The length of the side are also different. Again, solving for the C, we will be getting 17 if we use the Pythagorean theorem. And solving for each of the functions, this is what you will be getting. The opposite is 15, adjacent is 8, which you can see here on the tangent function. Can you solve for the trigonometric functions considering this triangle and this angle? And remember, you have a missing leg here. I will be showing the answer in 3 seconds, but feel free to pause the video. Okay, now that we are done with the review of how to do or how to use the Pythagorean theorem and the trigonometric functions of an angle, let us have a conclusion of why this is necessary. Why is the review important in dealing with vectors? Again, if you remember, vector quantities, you need to state both the magnitude and direction of the object. In the last discussion, we also saw that if we have to add vectors that are perpendicular angle with each other, meaning to say one of the vectors is along the x and one of the vectors is along the y, if we draw the resultant vector, we will actually be able to form a right triangle. So that is where the concepts of Pythagorean theorem and trigonometric function will be important, will come into play. Since we are forming a right triangle in our vector diagram, those two concepts are still applicable. So vectors, magnitude and direction. To get the magnitude of two vectors that are in perpendicular angle with each other, we can use the Pythagorean theorem to solve for the magnitude. And we can use one of the three functions, trigonometric functions, to solve for the direction or the angle. So let's say, for example, although we will have more discussion of this in our face-to-face class, let me give you a preview. We already saw this triangle before. So we have a force here, 40 newtons, but it is directed to the west or to the left. And we have another force, 10 newton, a much smaller force, but this time directed downwards. We wanted to to see the combined effect of the two forces. But again, we cannot just add or subtract 40 and 10 because now they are not acting in the same axis. So how do we solve for the resultant? How do we get the magnitude and the direction? To get the resultant, the magnitude of the resultant, we will be using the Pythagorean theorem. But you can see here that I replace C with capital R because that will be my symbol for resultant. And I will be getting this answer. If I want to get the direction of the angle, direction of the resultant rather, I can compute for the angle. Let me use the tangent function here, but you can use the sine and the cosine if you want to. For me, it would be easier to use the tangent function. So tangent is opposite, that's 10 over adjacent, that's 40. So 10 over 40 is 0.25. That's the value of my tangent function, not my theta here. So how do I remove the tangent here? So what I get is the value for the theta. So what you can do is to multiply both sides by the inverse of function, the inverse of the function, by the inverse of the tangent, which is you can see here as tangent with -1 raised to the -1. That means you are multiplying with the inverse of the tangent. If you do that, you will be able to cancel the tangent on the left side of the equation, and on the right side, meron kang you have tangent inverse of the tangent or the arc tangent multiplied to 0.25 or the arctangent of 0.25. So how do you put that in your calculator? You just click on shift first and then the button for the tangent and then you put 0.25. You will get the value for the angle. Angle have a unit of degrees or angle can be described in terms of degrees. So that's what we have here. So 14 degrees. So this is 14 degrees. This angle is 14 degrees. So your answer would be this way. The resultant is 41 Newton and the direction is 14 degrees. You can also include um, your references, your reference direction, meaning to say it's coming from the west, right? And then rotating towards the south. So you put south of west. But again, more discussion of this later on. Before you go, please answer the two concept check questions. Thank you.